Immune system. Our immune system is essential for our survival. Without an immune system, our bodies would be open to attack from bacteria, viruses, parasites, and more. It is our immune system that keeps us healthy as we drift through a sea of pathogens. This vast network of cells and tissues is constantly on the lookout for invaders, and once an enemy is spotted, a complex attack is mounted. The immune system is spread throughout the body and involves many types of cells, organs, proteins, and tissues. Crucially, it can distinguish our tissues from foreign tissue cells from non-cells. Dead and faulty cells are also recognized and cleared away by the immune system. If the immune system encounters a pathogen, for instance, a bacteria, virus, or parasites, it mounts a so-called immune response. Later, we will explain how this works, but first, we will introduce some of the main characters in immune system.
White blood cells. White blood cells are also called leukocytes. They circulate in the body in blood vessels and the lymphatic vessels that parallel the veins and arteries.
White blood cells are on constant patrol and looking for pathogens. When they find a target, they begin to multiply and send signal out to other cell types to do the same. Our white blood cells are stored in different places in the body, which are referred to as lymphoid organs. These include the following. 1. Thymus, a gland between the lungs and just below the neck. 2. Spleen, an organ that filters the blood. It sits in the upper left of the abdomen. 3. Bone marrow, found in the center of the bones. It also produces red blood cells. 4. Lymph nodes, small glands positioned throughout the body, linked by lymphatic vessels. There are two main types of leukocytes. Number 1. Phagocytes. These cells surround and absorb pathogens and break them down, effectively eating them. There are several types including 1. Neutrophils. These are the most common type of phagocyte and tend to attack bacteria. 2. Monocytes. These are the largest type and have several roles. 3. Macrophages. These patrol for pathogens and also remove dead and dying cells. 4. Mast cells. They have many jobs including helping to heal wounds and defend against pathogens. The second type of leukocytes is lymphocytes. Lymphocytes help the body to remember previous invaders and recognize them if they come back to attack again. Lymphocytes begin their life in bone marrow. Some stay in the marrow and develop into B lymphocytes, B cells. Others head to the thymus and become T lymphocytes, T cells. These two cell types have different roles. B lymphocytes. They produce antibodies and help alert the T lymphocytes. T lymphocytes. They destroy compromised cells in the body and help alert other leukocytes. How an immune response works. The immune system needs to be able to tell self from non-self. It does this by detecting proteins that are found on the surface of all cells. It learns to ignore its own or self proteins at an early stage. An antigen is any substance that can spark an immune response. In many cases, an antigen is a bacterium, fungus, virus, toxin, or foreign body. But it can also be one of our own cells that is faulty or dead. Initially, a range of cell types.
The role of B lymphocytes. Once B lymphocytes spot the antigen, they begin to secrete antibodies. Antigen is short for antibodies generators. Antibodies generators are special proteins that lock onto specific antigens. Each B cells make one specific antibody. For instance, one might make an antibody against the bacteria that cause pneumonia, and another might recognize the common cold virus antibodies are part of a large family of chemical called immunoglobulins, which play many roles in the immune response. Immunoglobulins IgG marks microbes so other cells can recognize and deal with them. IgM is expert at killing bacteria. IgA congregates in fluids such as tears and saliva, where it protects gateways into the body. IgE protect against parasites and is also to blame for allergies. IgD stay bound to B lymphocytes, helping them to start the immune response. Antibodies lock on to the antigen, but they do not kill it, only mark it for death. The killing job of other cells such as phagocytes. Role of T lymphocytes. The distinct types of T lymphocytes help T cells, Th cells. They coordinate the immune response. Some communicate with other cells and stimulate B cells to produce more antibodies. Others attract more T cells or cells eating phagocyte. Killer T cells, cytotoxic T lymphocytes. As the name suggests, these T cells attack other cells. They are particularly useful for fighting viruses. They work by recognizing small parts of the virus on the outside of infected cells and destroy the infected cells.
Immunity. Everyone's immune system is different, but as a general rule, it becomes stronger during adulthood as by this time we have been exposed to more pathogens and develop more immunity. That is why teens and adults tend to get sick less often than children. Once an antibody has been produced, a copy remains in the body so that if the same antigen appears again, it can be dealt with more quickly. That is why with some diseases such as chickenpox, you only get it once as the body has a chickenpox antibody stored, ready and waiting to destroy it next time it arrives. This is called immunity.
There are three types of immunity in humans called innate, adaptive, and passive. Number 1. Innate immunity. We are all born with some level of immunity to invaders' human immune system. Similarly to those of many animals, will attack foreign invaders from day one. This innate immunity includes the external barrier of our body, the first line of defense against pathogens such as the skin, mucous membranes of the throat and gut. This response is more general and non-specific if the pathogen manages to dodge the innate immune system. Adaptive or acquired immune kicks in. Number 2. Adaptive acquired immunity. This is protect from pathogens developed as we through life as we are exposed to disease or get vaccinated. We build up a library of antibodies to different pathogens. This is sometimes referred to as immunological memory because our immune system remembers previous enemies. Number 3. Passive immunity. This type of immunity is borrowed from another source, but it does not last indefinitely. For instance, a baby receives antibodies from the mother through the placenta before birth and in the breast milk following birth. This passive immunity protects the baby from some infection during the early years of their life.
Immunization. Immunization introduces antigens or weakened pathogens to a person in such a way that the individual does not become sick but still produce antibodies. Because the body saves copies of the antibodies, it is protected if the threat should reappear later in life.
Immune system disorder. Because the immune system is so complex, there are many potential ways in which it can go wrong. Type of immune disorder fall into three categories. Immunodeficiencies. This is when one or more part of the immune system do not function. Immunodeficiencies can be caused in number of ways, including age, obesity, and alcoholism. In developing countries, malnutrition is an common cause. AIDS is an example of an acquired immunodeficiencies. In some cases, immunodeficiencies can be inserted for instance in chronic diseases where pathogens do not function properly. Autoimmunity. In acquiring condition, the immune system mistake target healthy cells rather than foreign pathogens or faulty cells. In the sensor, they are cannot discern self from non-self. Autoimmune design include cells. Hypersensitivity. With the hypersensitivity, this immune system overreact in a way that damage healthy tissue in shock where the body responds to an allergen so strongly that it can be life-threatening.
Thank you for listening.